So this is quiz 134. I figured I'd go over the answers. On the screen you can see the location of the times where I cover the different problems. So you can fast forward to the problem that you need help with, or you can just watch the entire thing. Question number 1, if the log base 5 of 2 is equal to 0.4307 and the log base 5 of 3 is equal to 0.6826, using the properties of logarithms, what is the value of the log base 5 of 8 over 3? So first thing, I'm going to change this to be log base 5 of 2 cubed over 3. Then I can use my quotient property. So I have log base 5 of 2 cubed minus log base 5 of 3. And then using my power property, I can bring the 3 out front. So I have 3 log base 5 of 2 minus log base 5 of 3. Since the log base 5 of 2, they gave me up here in the instructions, is equal to 0.4307. And I'm going to be subtracting the log base 5 of 3, which is equal to 0.6826. Now 3 times this 0.4307 value gives me 1.2921 minus the 0.6826 gives me a final answer of 0.6095. For question number 2, we have the same information. Use properties of logarithms. What is the value of the log base 5 of 24? Well, log base 5 of 24 is 2 and 12, which would be 2 and 6, which would be 2 and 3. So once again, I have 2 cubed, so I could write this as the log base 5 of 2 cubed times 3, or as the log base 5 of 2 cubed plus log base 5 of 3, using my power property as 3 log base 5 of 2 plus log base 5 of 3. Once again, I have 3 times the log base 5 of 2. The log base 5 of 2 is 0.4307. And this time I'm adding my log base 5 of 3, which is the 0.6826. Multiplying that out again, I get 1.2921 plus 0.6826. Give me a final answer of 1.9747. Question number 3, I'm supposed to solve log base 8 of x plus log base 8 of x plus 7 equal to 1. I'm going to use my power property first, so I can rewrite this as the log base 8 of x times x plus 7. So I converted that addition of the logarithm into multiplication of my argument. Distributing, I get log base 8 of x squared plus 7x equal to 1. Now I'm going to convert it into exponent form. So my base is 8, my exponent is the 1, and that is going to be equal to my argument of x squared plus 7x. Getting it into standard form, so setting it equal to 0, I have x squared plus 7x minus 8 when I subtract 8 from both sides. And then I can factor. I can factor into 2 binomials, x and x, for the first part of my binomial. I have a negative as my final sign, which means I have opposite signs in my binomials. Factors of 8 that give me a difference of 7 would be 8 and 1. I need more positives, so I'm going to put the positive with the 8 and the negative there with the 1, which means x is either equal to a negative 8 or a positive 1 value. I do need to check my answers. If I plug in a negative 8 into my original up here, you will see that a negative argument is not possible. So I do not need the negative 8. My only answer is x is equal to 1. On number 4, you just had to use a calculator to evaluate the log base 10 of 7 52, and that gives you an answer of 2.8762. Question number 5. We're supposed to solve 4 to the 2m power is equal to 130. So what I'm going to do first is I'm going to take the log of both sides. So I have the log of 4 to the 2m equal to the log of 130. Using my power property, I can bring the 2m out front. So I have 2m log of 4 equal to the log of 30. And now I'm going to divide both sides by 2 log 4, which is going to make m equal to the log of 130 over 2 log 4. Using my calculator and figuring out what the log of 130 and then dividing by 2 log 4, I get a value of m being equal to 1.7556. Question number 6. I need to solve for x. I do not have like bases, so I can't just set their exponents equal to each other. Instead, I'm going to take the log of both sides. So I have the log of 5 to the x plus 4 power equal to the log of 2 to the 3x power. Using my power property, I have x plus 4 times the log of 5 equal to 3x times the log of 2. Now you can substitute in the values for the log of 5 and the log of 2 at this point and then distribute. Most people prefer that. I am going to go ahead and do that. So the log of 5 is equal to 0.69487. So I have x plus 4 times the 0.69897. That's going to be equal to 3x times the log of 2. The log of 2 is 0.3010. Now distributing, I have 0.69897 times x plus 2.7959, and that is going to be equal to 0.9031. I'm using the exact values, that's why I have a slightly different number than just multiplying the 0.3010 by 3. Now I'm going to combine my x terms. So the x terms would be this guy here as well as this one here. So I'm going to go ahead and subtract the 0.69897. So that gives me 2.7959 equal to 0.2041 x. And now if I divide the 2.7959 by my 0.2041, I will solve for x. So x ends up being 13.697. And then for number 7, you're supposed to use a calculator to evaluate the log for base 4 of 83. So that is equal to the log of 83 over the log of 4. That gives you a total of 3.1875.